Hello friends, welcome back to our channel Mirror Neuron, which means watch and learn. And today I'm going to start a new playlist in our YouTube channel, and that would be a playlist where I will post a totally different kind of videos. Which I mean is I'll be sharing my experience doing some fundamental research in this field of deep learning, and especially in the field of image processing or identifying objects or stuff from your images and videos. And my main goal here is maybe if I am being very hopeful, to eventually find a better technique to do deep learning, right? And my main goal that I'm starting with is, can I learn from a single image? I'm not talking about where I will be giving input of hundreds and thousands of image, but instead I will just give in one image, and my output will be that I will have another four images of different things, and it should be able to identify which item did I see. A very small project, but equally challenging, and this book actually has encouraged me to do that. So if you I'll give you a brief history of, or a brief summary of this book. This book is the Double Helix by James Watson, and you probably know Watson and Crick, who figured out the shape of the DNA, right, the structure of the DNA, back in the 1950s, right, and they got a Nobel Prize for that. Now, what encouraged me from this book was that we all think that Watson and Crick have figured out the model by themselves, but from this book I came to know that I was wrong, and they actually figured out because they actually read the research paper of many people, including Linus Pauling or Morris, and the pictures which of the X-ray pictures which Rosalind Franklin took during her experience with DNA and so on. And what happened was, the knowledge of Watson and Crick got shaped by the findings of other people or other scientists at those days, and eventually it led them to the discovery of the structure of DNA, right? And this book actually covers all of this. But my topic today is not from this book, but the encouragement that I got from this book is that maybe each one of us probably have all those information, and if we do research, and by not just following what others have done. I am great, I Andrew Ng, Jeffrey Hinton, Jan LeCun, and Yashua Benjo, they have really inspired me a lot. But then what if their research, their help, and their findings can help one of us or guide one of us in totally a different way, and help us find a simpler way to do deep learning, instead of doing so much of back propagation and so much of gradient descent, right? What if there is actually maybe a simpler method? I want to explore that part. Although these folks are continuously doing research, I'm pretty sure they are way smarter than I am, but I believe that if I can take a totally different track, and if I am proved wrong, I would be more than happy. But then I can always come back and learn and continue the research on CNN or RNN, etc., and different kind of models. But to a certain extent, maybe a different journey might yield a different result. And I'm starting with this particular course here. It's available in YouTube as well as in the MIT OpenCourseware. You can just Google search the Brain Minds and the Machine Summer Course, and if you go to the Brain Minds, and this is I'm sharing it with everybody because this is what I'm currently doing, and and I hope if you find an inclination towards it, maybe we can eventually at some point of time we can collaborate and think more about it, how to solve this problem. So if you see here, they have very interesting introductory content here: neural circuits of intelligence, modeling human cognition, development of intelligence, visual intelligence, and so on. Currently I am on this unit 4, and I really like the way Shimon Ullman has been presenting the material out there, and surprisingly I could prove those points just using the NumPy library. right? And I'm sorry, just by using the numpy library I could use some of the basic fundamental concepts from numpy and show that why this deep learning method that currently that we are doing might not work in the long run, right? So this is all I wanted to talk about today, and I hope this gives also a new angle to think about. So why don't you join with me in this journey, and let's see what we can stumble upon, right? So let's see, and I'll keep continuing sharing my experience, what I have learned, and what worked for me, what did not work for me, and you'll find all of those in this playlist here. So right now I'm planning to complete all the video lectures here. There are a bunch of them. It might take me a week or two to complete those. For the next 2 weeks I'm just focusing on learning how to use more of the TensorFlow 2. I've been coding so far on TensorFlow 1, but currently I'll be using TensorFlow 2. Just for me, I don't invest too much time on figuring out whether I should go with PyTorch or TensorFlow or basic NumPy. But then, because they are there, they make life a little bit easier. So why not stick to one, right? Maybe later on I can switch to PyTorch. But right now I'm focusing more on TensorFlow 2. With that, I'll close this video for today. But until next time, I'll try to share some progress, or if not, some failure, so that you can learn from that as well. All right, you take care, and I'll talk to you next time.